So now since we have also already done the positive real lemma, there are variations of the positive real lemma. If you remember the positive real lemma, ultimately in the statement about the matrices, there is the specific matrix matrix P, which is a positive definite matrix or positive semi-definite matrix. Now, this positive semi-definite matrix during the proof of the positive real lemma, or in fact when I showed that the existence the existence of those equations are equivalent to the system being passive, I had made use of the fact that this matrix P defines the storage function. Now, this, if P is a positive definite matrix, then the storage function is positive definite. If P is a positive semi-definite function, then the storage is positive semi-definite. Okay. Now, between the situation when the storage function is positive definite and the storage function is positive semi-definite, there is a slight problem, and this problem is very much similar to the kind of problem that you would get when you use systems with inputs, no outputs, and you are using Lyapunov theory. Now, in Lyapunov theory, when you take a function which is positive definite, then that actually guarantees whatever is the conclusions that you can draw from using Lyapunov theory. Whereas, if you take something which is positive semi-definite, you cannot utilize it to the full power of the Lyapunov theory. Yeah. So, you cannot as a Lyapunov function candidate, you have to always take something which is positive definite, and you hope that its derivative is negative definite. But if the derivative is negative semi-definite, you cannot draw that strong a conclusion. Yeah, I mean your conclusions that you can draw is weaker, and so on and so forth. So, in the same way, in exactly the same way, as far as storage functions are concerned, when you have positive definite storage functions, it's good, and when you have positive semi-definite storage functions, it's not that good. And the statement of the positive real lemma only guarantees that the storage function is positive semi-definite, not positive definite. Now, in order to guarantee the positive definiteness of the storage function, one brings in this additional thing. So, there we had shown that positive semi-definite storage function, positive semi-definite P, and those other matrix conditions are equivalent to the transfer function being positive real. Now, one can give an additional thing, which is additional definition kind of thing, which guarantees that the storage function is strictly positive definite. Now, the storage function being strictly positive definite is equivalent to the transfer function being strictly proper real. So, we have already given some definition for GS being positive real. Yeah. So, there is a Nyquist condition and so on and so forth. Now, we say G of S is strictly positive real when G of S minus epsilon is positive real. Yeah, for epsilon greater than 0. Epsilon greater than 0, small for small epsilon greater than 0. Okay. What we mean by this is, you see earlier when I was talking about positive realness, I had said that of course, this is a map G of S. So, any point S goes to the corresponding point here, and the imaginary axis mapping to something, and then the right half mapping to the inside, of course, is the good thing that can happen, and that is the definition of positive real. Okay. Now, in this particular situation which I have drawn, where the imaginary axis maps to this and the right half maps to the inside, clearly if instead of g of s we take the map g of s minus epsilon, that also would map to some neighborhood of this. And so in fact this particular situation g of s is strictly positive real. It might happen that you have some plot which looks like that. The imaginary axis maps to something like that, and then the right half plane perhaps maps to something like that. And now if you look at g of s minus epsilon, then the perturbation might be such that this gets moved like that. And because it gets moved like that, g of s minus epsilon does not satisfy the positive realness condition, and so this will not be strictly positive real. And this touching in the imaginary axis of this area, this region, it maps to some other region here, and that region, how it touches the imaginary axis, that in some sense defines the positive definiteness and the positive semi-definiteness of the storage function. And so when you do this g of s minus epsilon, that means you perturb by epsilon, in some sense what you are doing is you are moving this imaginary axis. And so if there are these places where it touches the imaginary axis, this image, then when you shift the imaginary axis, then those things get mapped to the left half, and g of s minus epsilon does not remain positive real. So such things which are on the boundary, they are not strictly positive real, anything else is strictly positive real.